Hello everyone, I'm Amir Hussain. Welcome to this training video. In this video, we see how to run the MOZBC utility and make initial condition and boundary condition values for some specific particulate matter and gaseous variables for your WRF Chem domain. So I'm in the MOZBC directory, but before running MOZBC, you need to run the real.exe utility for your WRF model. So I go to the WRF run directory. Here I open namelist.input. Before running real.exe, let me show you what happens if you disable chemical process here. So for the first time, I want to set Chem option to 0. For the second variable, for the second value, you don't need to touch it because it's just for one domain. So I set chemical option to 0. Now if I run real.exe, if I open WRF input, inside WRF input, you can see 31 variables. WRF input is actually your initial condition. And if I open WRF boundary, here you see 80 variables. So this is the condition for running real.exe without any chemical process. Let me open WRF input again. Inside the WRF input, you cannot find any gaseous variable or particulate matters, such as let's say NO2 or SO2 or ozone or something like that. Now if I open namelist and I set chemical option to some value such as 301, I'm not going to discuss in details about these variables. You can study the manual or user guide of the WRF to see what is the meaning of these variables or these values. I set it to a number 301, and now I run it again. I show WRF input. Now you can see that there are 97 variables after setting chemical option to a variable. Inside of this, you can find a lot of particulate matter and gaseous variables. For example, let me see NO2, nitrogen dioxide. If I open nitrogen dioxide, you cannot see a significant pattern here. Also, if I open something else, let's say NO3, you can see some pattern here, a distribution here. If I show you SO2, there isn't any significant pattern here or a significant distribution for the mixing ratio of SO2. So it seems that you have some initial conditions or initial value for the variables. However, the pattern is not much clear. It seems that these patterns are set by some default value by the model itself. So MOZBC is going to put some initial value and boundary value for your WRF input and WRF boundary files. Okay, so our WRF input and WRF boundary files are ready. We can go to the MOZBC directory and run the MOZBC utility. For running MOZBC utility, you need an input data, and for making that input data, there is a utility or there is a code that you can use that code to generate that input data. So you can run MOZBC in a very easy way. How you can get access to that code or utility, go to this repository atmospheric science. I will provide the address to this repository in the video description. Copy the address to this repository, copy the address, and git clone it here in this directory. Okay, the repository is atmospheric science. I go to atmospheric science. There is a WRF tools directory here. I go to WRF tools. Inside WRF tools, there is two directories, one for PrepChem sources. If you have watched the previous video for PrepChem sources, there is a utility that you can use inside this PrepChem source. You can actually find a utility that you can use to generate PrepChem source input file. And there is a similar utility for MOZBC. If I go to MOZBC, you can find a code or shell script that you can use to make your MOZBC input file in a very easy and simple way. So I copy the absolute path to this code. I get back to the MOZBC directory and I copy this code here. Now I have access to the code, to the utility code that can help me to generate MOZBC input data, MOZBC input file. I open it, I open set MOZBC input. Inside here you have to set 3 variables. So before running this code, you have to set 3 variables here. The first variable is the absolute path to your WRF namelist.input. So I go to my WRF run directory and I print namelist.input path. I copy it, come here, and I paste it here. So the second one is the MOZBC directory path. MOZBC directory path is the current directory, the directory that we are working inside it. So I print the working directory, copy it, go back to the code, and I paste it here. And the second and the third variable is the vacuum file or the Chem chemistry file, which contain the variables that MOZBC read, initial conditions and boundary conditions, and write it in your WRF input and WRF boundary files. So this file should be inside your directory. So you're not supposed to give an absolute path or give an absolute address of the file. It should be directly copied or linked inside this directory. So I just copy the name. This is my vacuum file. I just copy it. I open it and I paste its name. So you can see that there isn't any slash here. There isn't any slash here, just a file name. And now you are ready to run this code. After running this code, it will try to find some available variables, some available gaseous agents or particulate matter. And if it finds it in both your WRF input file and your vacuum file, it tries to read it from your vacuum file and write it to your WRF input file. Just run it. I run set MOZBC input. It is successful. The first line is actually a warning message. It's actually want to be it wants to be sure that you have run real.exe successfully. So after running, our MOZBC.input file is ready. If I open it, MOZBC.input, this is your MOZBC input file. This is the file that you can use to run MOZBC and update your WRF input and WRF boundary file. How you can run MOZBC using this input file? This is the command that you can copy and paste here. Okay, it has been run, and now if I get back to WRF run directory, if I open WRF input, let me show you some variables. Let's say NO2. If I open NO2, now you can see that your NO2, the distribution of NO2 has been changed, and actually there is a reasonable or a logic distribution, something that is significant. You can see something significant, significant distribution here. Also for SO2, there is SO2 here. Also for SO2, the initial conditions for SO2 has been changed. So MOZBC has read the SO2 from the vacuum file and wrote it here in the WRF input file. Now you have initial conditions for these variables, SO2, NO2, and other particulate matters. What is this particulate matter? HNO3. All of the gaseous variables, all of the particulate matters have now some initial condition or initial values. The same situation is for WRF boundary. If I open, let's say, something from here, you can find some boundary conditions here that were absent in the previous file. Now after running MOZBC, you are ready to run your WRF, your WRF Chem model. Just run WRF.exe. It starts to run it, and the difference between this run and the previous run is that now you have some initial condition and boundary conditions, and it is supposed to be more accurate in comparison to the previous run. So MOZBC, without MOZBC, as I told in the previous video, without MOZBC you can run WRF Chem, but by updating your initial conditions and boundary conditions, you will reach more accurate results. This is actually a very small domain and it's pretty fast, but for larger domains it will be significantly longer. I'm just waiting for the next saving. 50. Okay, it has been saved. I just stop it and open WRF out. Inside WRF out, let me show you the output of the WRF Chem for NO2. This is the output for NO2 for 3 time slots. Okay, this was actually for one domain. In the next domains, I will show you how to run the WRF Chem with nested domains or with more than one domain.